Hello, Deep Tech community. I highly appreciate to be here today with you and have opportunity to share our successful story at 2 a.m., which developing additive manufacturing and advanced materials. And today I will tell you about innovative metal additive manufacturing for the space industry. So we are a space tech startup. We born in commercialization reactor, and we are developing new technologies and materials for 3D printing on the air here, but also we want to expand to the moon market. But before to go to the future, let's start from the history. Everyone knows, of course, who is Leonardo da Vinci. He was Italian polymath who invented a lot of technologies, but them did not work. Why? Because this time it was not enough materials for developing this technology. This shows how is important material, because if there is no material, you don't have technology. It slowed down progress a lot. And after many years, the White brother developed first plane. It was made from the fabric and wood and was poorly suitable for aviation. But only 16 years later, the Junkers invented and developed aluminum-based plane, and it took off to the air. So this was first successful plane from the fully metal alloys. And additive manufacturing is a novel technology which is growing, and additive manufacturing is also growing. And these all sectors, space, automated defense, and energy, using also additive manufacturing. But the problem is that there is not enough suitable materials for these technologies. New technologies requires new materials. And why conventional method is not good anymore? Because it has low buy-to-fly ratio. It means it's more expensive. It can be even 40 times more expensive than a raw material. It has slow manufacturing, and it can be up to 90% of waste. And our big motivation, as you probably all know, last year, Relative Space launched into the space 3D printed rocket. It's almost fully printed. And here in Europe, unfortunately, we are far from this result, but we are going to this direction, as we can see around. And the big challenge that of additive manufacturing, that existing 5,100 alloys, and only 1% of all of that can be used for 3D printing. And conventional, traditional high-strength aluminum alloys are not suitable for 3D printing. And we found solution, is very important solution, and I hope you understood that materials are very important for our technology. That's why we developed new materials which has low buy-to-fly ratio. It means they're cheaper, it has fast manufacturing, it has high performance, and it has less than 10% waste. So it means it's also sustainable technology. And there is characteristic, what we achieved, technical characteristics. It has low densities, materials are stronger, it's also lighter, and this is super important for space and aviation industry. And the main point that all of them are suitable for 3D printing. Last year, we successfully completed European project funded by European Development Fund, and it's called Metal Matrix Nanocomposite. We developed composite combined metal alloys with submicron ceramic particles filler. So it means that we made with this project material with higher physics and mechanical properties, which is very important for aviation and the space industry. And we also improved the process itself, the method. And now we are starting European Space Agency project, and our goal is to develop innovative technology for strengthening materials during the 3D printing process. So it also will allow to use this method for large-scale samples for the rockets and other space applications. For example, we plan to print typical rings in launch vehicles completely will be printed, and tank of the rockets, and flange for the rockets, for the solid rockets. So it's important to have the very strong, high-strength materials and good quality, because it's space. Here you can see that everything is going well, and this is for us, and there is our main customers and partners with who we have memorandum of understanding and negotiations and close collaboration, and so far we signed more than 10 such agreements. This is just the key end users and partners for us. As you heard today about Artemis mission, it's the moon mission. So let's look to the future. To the future, as I mentioned, we started from the history, and now we look to the future. The humanity mission is to make the moon as a place as a main point for another application. So it's called in situ resource utilization. So its maintenance operation will be directly there. And Artemis will send the first woman to the moon, and it will be sent later on the first astronaut also to the Mars, and it will be the camp also based directly on the moon. And also in Europe we have European Space Resource Innovation Center. It's the first innovative center based in Luxembourg, who is orientated completely on space resources and in space economy. That's why we also created another startup. It's called LuxIM, which is also orientated to the space, and we successfully went through acceleration program Fit for Start under guidance of Luxembourg Ministry of Economy. And we want to be part of these missions because the lunar exploration market is estimated for 170 billions and is growing, and there will be 400 missions for next years, and we want to be part of this mission. So that's why our goal to maintenance, repair, and make operation directly on the moon. But in our case, we plan to print components using also lunar regolith directly on the moon. Please join our future with 2AM. Thank you.
Jekaterina, thank you so much for the concise presentation. Just a very, very quick question. Why is your company called 2AM? That is one of the attendees asking that question.
Okay, it's a good question, because in the morning I was thinking to say what it means and to say the joke about 2 a.m. because many people probably think it's 2 a.m. in the night. It doesn't mean that we created it in 2 a.m. in the night. Even we work late sometimes, it's true, but it means advanced materials and additive manufacture, so double AM.
Okay.
2 a.m.
Thank you so much. Thank you, and all the best in your research efforts and
Okay.
developing them into the business.